So hopefully everybody has seen the break in the one-on-one breakout room sign up form that I think Laura posted. So follow that URL and sign up for the one-on-one that we have. We have several breakout sessions and experts there, as mentioned. We have IDE integrations, debugging, sanitizers, and providers. Um, and I'll be introducing some of the experts that will be there with you in a little bit. Um, if you like the one-on-one with our experts, please be sure to fill out the form, as I mentioned, and it's a first come, first serve. Um, I'm going to start with an introductory set of slides, and then we're going to go into Q&A. So get your questions ready. Um, while we're while I'm doing the introduction, there's going to be a team behind doors figuring out who's going to go into which of the breakout room sessions. And everybody else will be staying in this room, in the main room. When it's your time for the breakout room, you'll be automatically put into that breakout room. So you will have a one-on-one session there, and everybody else will stay, being able to put into the Q&A chat window. So if you have any questions there, everybody will see it. And as mentioned, Sebastian and Holly will be able to help me answer some of those questions. Note that in the breakout room, the mic and camera will be activated. I know it was mentioned in the video, but we want to make sure that you're fully aware. In the common room, which is where we are, you only have access to the Q&A. So your mic and your camera is not activated. So with that said, I'm going to go ahead and do a quick introduction. As I mentioned earlier, my name is Rafael Campana. Everybody knows me as Rafi. And I'm the Director of Engineering for Compute Developer Tools. And with me, I have Holly, who is the Engineering Manager for Platform Tools, and Sebastian Domine, who is the Senior Vice President for Developer Tools. And with us, we have several experts in the breakout rooms. So we have Daniel Horowitz, Director of Engineering for Platform Tools, and he's in the Insight Systems breakout room. We have Magnus Strengert. He's an Engineering Manager for Compute Profilers. In the breakout room that he'll be in is the Insight Compute. We have Steve Ulrich, Engineering Manager for Compute Debuggers, and he's going to be in the Debuggers and IDE Integrations breakout room. And Aurélien Chartier, and he is the Senior Software Engineer for memory checkers, and he's in the Compute Sanitizer breakout room. So to give an introduction or a quick kickoff on our set of developer tools or offerings, I'm gonna show you 4 quadrants here, going from top left all the way down to top right. So on the top left, we have a set of debuggers. We have the command line CUDA GDB on Linux. We also have the Insight Visual Studio Edition, which obviously runs on Windows, for Windows. And we also have a fairly new product called Insight Visual Studio Code Edition, which is similar to the Insight Visual Studio product that plugs into Insight Visual Studio Code. So it gives the same functionality as what you see in Visual Studio and with Insight Visual Studio, but this time with Visual Studio Code. So you get, IntelliSense, you get debugging and everything the same as you were on the CPU, and you also have the CPU debugging as well. The underneath debugger for Insight Visual Studio Code Edition is CUDA GDB actually. So any interaction that we have with CUDA GDB will be populated in Visual Studio Code with it. On the right, to the right of that, we have profilers. Insight Systems gives you a system level view of what's happening with your application or happening whenever your application is running. So you'll be able to see any other processes that may be running at the same time. You can see CPU threads, occupancy, where the allocation of each of the cores is for your application, for your processes. all the way down to GPU activity. And it's all in a timeline. So it's very nice to start off there, and we'll be talking about that in a little bit too. Insight Compute gives you, after with Insight Systems, after you get to a point where you found a kernel, basically the CUDA GPU workload that you want to focus on, then you're going to switch to Insight Compute. Insight Compute is a profiler, kernel level profiler that allows you to narrow down bottlenecks that are happening within the kernel. So it's very much on a kernel level, and you can see high level information about, like, for example, if the kernel is memory bound or compute bound, and then you can go all the way down to an instruction level of why your application in that point is being bottlenecked or slowed down. CUDA, which is our CUDA profiling tools interface, is available for you to either write, build in profiling information into your application, or for tool developers. So if there's any third-party developers that would like to create their own tools, profiling tools, you can do so. We have the NVIDIA Tools Extension, or NVTX, which is a way to annotate your code with sections of how much time you're spending, and it's visible in all these tools. Is available on Insight Systems, is available on Insight Compute, and we're actually making it available on other ones like Compute Sanitizer as well. Going to the bottom left, we have Compute Sanitizer, which is our correctness tool. And this tool is comprises about 4 other tools under the covers. We have a memcheck, which is memory access error and leak detection tool. And all this is, by the way, at runtime. We have a race check, which reports issues on hazards to accesses to shared memory data. We have a init check, which is the one that detects any accesses to memory or global memory on uninitialized device sections or variables. And also we have sync check, which is the thread synchronization hazard detection tool. It's available on several platforms and on the CLI, and we also have an API, an SDK for it, so you can build it into your application as well. And in the bottom right, we have IDE integrations. I had mentioned already Visual Studio, inside Visual Studio, which plugs into Visual Studio. Also inside Visual Studio Code Edition, which plugs into Visual Studio Code. But we also have plugs into Eclipse, which is called Inside Eclipse Edition. And these are, Inside Eclipse Edition is available for Mac as a host and on Linux. And just a quick update or reminder about all the sessions that we have available at GTC. Sorry, let me check. All the sessions are available for GTC, which are related to our team sponsoring, or we have any some type of inclusion in it. So with that, I'm going to open it up for any Q&A, as well as the breakout sessions will start now. So you will see yourself getting into the different breakout rooms now. So any question that have come up, Seb or Holly? I haven't been paying attention much.
Well, a couple of questions come up, but they were answered by Steve. The first one was, if I'm not mistaken, TUI mode was removed from CUDA GDB. Why? Will it come back? And Steve responded that there were some dependencies with ncurse across various distros, and as such, we kind of disable that feature for now until we can resolve the engineering aspect of supporting different distros with regard to ncurse. And the other question was around scrolling up, Paul, who was having problems debugging the eigen library in CUDA, and Steve again was asking Paul if in order to debug CUDA, you need to make sure that you compile with the -G, which is for generating the symbolics and then disabling optimization. And so we wanted to make sure that that Paul was doing that. And because it's a header file, is there anything specific towards that?
And Seb, just to clarify, there's a -lowercase g for CPU side debugging and a -uppercase G for GPU side debugging.
So we want the uppercase G. But the header file shouldn't have anything to do with it, right? It's just
it'll be the compilation unit where that header file is included.
And a new question came in. I am using NVML to measure GPU utilization, but the GPU value of the NVML utilization structure is updated every 1/6 of a second. So I couldn't get a granular value below that. Is it possible to get more granular GPU utilization information by using inside systems or inside compute? Yes and yes, and CUPT. So NVML is really used for monitoring the GPU, which is more of a system admin type of scenario. If you want a lot more finer grain performance counters collection, you can use inside compute or inside systems. Inside system has a new feature that's called GPU metrics that allows you to collect performance counter at a high frequency, meaning between 10 kilohertz to 100 kilohertz. I think you have to configure it in your session, but we recommend around 10 kilohertz for this particular for inside systems, and you will get basically not only GPU utilization but much more productive, I would say, metrics around useful work that the GPU is doing. GPU utilization is very high level metric, so it could be utilized but not utilized to do useful work. So if you want to drill down to the next level of perf metrics, we recommend you to use inside systems or inside compute. The GPU metrics activity in inside systems or the GPU metrics collection in inside systems requires an Ampere GPU. It's a new feature of the GPU. I need to scroll down. Hang on.
I see a question about what ID is preferred by the team, inside Visual Studio Code Edition or inside Eclipse Edition. Well, that's
by which team?
Yeah, no, that's exactly. It's I think it's a preference, right? We're providing the support for both of these IDEs, so it's it's your preference. There is a lot of, as you may know, there's a lot of momentum going on with Visual Studio Code. Lots of new functionality coming online. Lots of platforms being supported. A lot of remote and Docker support, which I know that Eclipse has as well. But I think at the end of the day is your team preference, really.
Yeah, I mean, I would say we love them all, and then even like VI or whatever, it's really. But if there is a special IDE that you care, let us know.
Or even within VS Code, especially if there are deficiencies or enhancements that are high on your roadmap. VS Code is a more immature product compared to our Eclipse support, and we are actively working on the roadmap. So feature requests and enhancement requests are warmly accepted.
Are there any docs to describe how to inside compute measures L1, L2 cache hit rate? So I think there is some documentation on all the metrics that are being used to calculate not only cache, but in general, what we present to the users. So I would definitely start with the docs. There's also another talk that
the report, the expert system in the report should also have some lights. No, you should. That's
so yeah. definitely there is some information in the sections, and if you mouse over the metrics, you'll be able to see more of the information there. But yeah, the detailed one will be the docs. On a similar note, let's see, 1, 2, 3. Number 3 might be of an understanding of a good interest to you. How to understand and optimize shared memory accesses using Insight Compute. That Magnus will be presenting. I think it's tomorrow. Will be kind of along those lines, and it's a deep dive. And last year he had another one which was very popular as well that I will recommend. On that one day that I used MVI top,
Yeah, it's
that one of my
I don't know.
GPUs was running at almost 100% utilization, but there was no user running a process. I was just possible, and how can I debug this? So yeah, that is very strange. I would say, the team here does not. We don't maintain MV top, so I'm not sure of all the inners of what they use to calculate, utilization. Um, I would say maybe comment in the forums and see if there's any support that you can get there. You can also file a bug as well. Want to debug and profile multi-GPU kernels? Do we have any best practices? Good question. I don't think there's any specific best practice. The tools are multi-GPU aware. Let's put it that way. You'll be able to see all the process, start with Insight Systems, I would say. And how to
Right.
apply that. But
Well, I mean, what I was going to say is the only way you're going to be able to observe the overall system is, or those GPUs, all those GPUs actually running concurrently and whatnot, is via Insight Systems, right? So that should be your first step in your perf triage, and then after that you're going to have to orchestrate, how those GPUs are executed and make sure they're not stealing each other, make sure there's concurrent, execution, make sure the memory movement is not incurring any stalls or whatnot. And then after that, if you want to improve your kernel, you're going to have to use Insight Compute and do kind of the work in isolation. Now the trick though is sometimes what you can optimize for in isolation means that the overall system is going to get faster. So that's part of the feedback loop of iterating between Insight Compute and Insight Systems.
The newer GPU metrics sampling, though, will let you do extra things like observe NV links if that's what you're using for multi-GPU. Also, PCI Express peer-to-peer transfers, how many SMs you're using. So there's still a good chunk of information that you'll be able to see system-wide with Insight Systems to help with that transition.
Yeah, good point, Daniel. And the multi-report is also available. Daniel?
Yes, indeed.
Yeah.
Yeah, so you can either take a look at the big picture of everything that's happening at the same time, or if you're running a bunch of different processes with something like MPI, you can bring those different reports back together into a single timeline. So there's a lot of flexibility in how that all works, and that's done through, there's like a file import to add extra reports into a single timeline.
Thank you, Daniel. And just a quick reminder to everybody, you can sign up for the one-on-ones, for the breakout rooms. The form is on the room chat. If you don't mind clicking on it and getting in with one-on-ones with some other experts. All right, so next question I see is Insight Systems question. Maybe this is for Holly. I had 15 individual symbols files, various libs to add as symbol locations on Red Hat using NSYS. Is there a way to chain the library entries into a list from the UI? Or is there a text file, config file I can edit under the hood? I had to add one at a time through the UI, kind of painful.
So this might be a time when your best bet would actually be to use the CLI instead of the GUI to run it. Then you could set up your command line run with the location of those libraries and run it once and go. We have talked about adding an additional configuration file that would let you do this, but currently we don't have that available for users. Wish I had better information for you.
It will also pick up symbols from the usual locations.
Right. Default locations.
Yeah, I don't know if we're talking about Linux or Windows, but where your debug symbols would normally go for any installed packages, or if you leave the symbols, don't strip them off the executable itself, then it will pull them off of there as well.
Right.
And you can still compile with as optimized code and leave the symbols on there.
I see. Thank you, guys. Sorry, I'm jumping onto another question here. Steve, maybe this is for you. Not 100% sure if it's debugger. I assume so. Somebody was working with 3D data, and they used the thread IDX, XYZ, and they were using it on Pascal and earlier architectures, getting wrong values. But then they switched to Turing, and the code worked fine. Any ideas what caused that? I assume this was a debugger issue, not.
Yeah, I'm looking at that. Nothing is jumping out right off the top. This might be a little bit larger than we can debug in this session, but getting a reproducer or getting some sort of a use case that we can test. Debug and release mode on Linux and Windows.
Oh, it was on both Linux and Windows?
Okay, if you have a bug report or a posting number that I can follow up on, I can take that offline. I'm not actually familiar with the specific issue, and nothing right out of the gate is coming to mind. And we depend upon thread indexes for all of our internal testing. So something along those lines is unlikely to slip through any form of cursory testing. So it's intriguing. I can't think of anything off the top of my head, but I will investigate.
Thank you, Steve. I don't see anything right now. A lot on the here. For profiling on AGX Dual Xavier Pegasus, I could only find a rather old version of Insight Systems. I got error messages related to NV Media and an error, and I read in the developer forums that there are problems with the DGPU. Is this old version 19.3, I think, the best I can get, and are the bugs likely to get fixed? Neil or Holly?
So the current version of Insight Systems is 2022.1. So there are more recent versions.
Yeah, but
GPU.
I think Holly, it could be. It depends on the version of DriveOS used. We have a specific version for DriveOS and for Jetpack, for Jetson, systems. And because on DriveOS, typically if it's 19.3, we need to know what version of DriveOS this is using. Is it the 5X or 6.0? And those are typically shipping with older versions when nothing has changed. So it's DriveOS 5.1.6.
Linux. Yeah.
Yeah, DriveOS Linux, but I see now it's 5.1.6. I don't remember on top of my head what is the latest version. I can try to maybe dig it up. in the meantime. But 19.3 seems old.
Yeah, that's super old. I'm sure there's
Yeah.
been a newer version on DriveOS
Yeah.
before them.
Let's see if I can find.
I had to modify my application to be able to use the tools. So the answer is no. Unless I would say unless I mentioned NVTX or the NVIDIA Tools extension. So if you want to annotate your code so that the tools can make use of it by presenting it in the timeline with your strings and your colors. But for the most part, no, you don't. You don't have to use. The only thing I would say is, for debugging, we need debug information. Just like we mentioned earlier, you need the -G switch to be able to debug something. On the profiling side, you don't need anything except for if you want to do source code relation from, let's say, you want to know, your C code, where the bottleneck is to assembly instructions, SAS instructions. We rely on the line table. So there's a switch called, and it's is in the ID integration. You will see it as, I think it's called line information. On the command line is, I think it's -- line info. So you need to turn that on. But, other than that, you don't need to modify anything in your application itself.
And to answer the DriveOS inside systems, I am not on VPNs. I had to remove the VPN, so I cannot find the answer. I'm sorry. But as a best practice, we do provide SDK Manager, and SDK Manager not only allows you to flash, your device and whatnot, but it will also install the latest, greatest tools for you. So that's also a good way to to make sure that you are using the latest software available for that particular version of DriveOS.
One, how can I profile my deep learning application DNN layers? Do you want to take that one?
Who? Holly.
So honestly, the easiest way to profile your DNA layers is to take advantage of the NVIDIA Tools Extension API and label them in the code. That way, when you run Insight Systems, it will automatically show up on separate lines, and it's easy to tell what section was relevant to what layer. That's how most of our internal teams do it, and that's how most people have done it successfully outside. There's full documentation of NVTX available on the web, and as well as if you go through the Insight Systems documentation, we'll give you links over to that.
All right. Let's see. Next one is, what is the best way to tune profile heuristics across a range of problem sizes? As an example, tensor transpose with fuse pointwise operations.
Want me to take this one?
Sure.
Yes, please.
Well, the way I would solve this is you have to essentially set up a CI/CD kind of scenario, right? Continuous integration and then continuous deployment with a bunch of unit tests, and then for each of those tests, you can use either Insight Systems or Insight Compute to collect some metrics through a command line in automation. And then upon a report being generated, you can load those reports in various fashion to essentially collect the metrics and regress them against a gold image. So this is kind of, do-it-yourself type of regression testing environment and see basically as you vary those parameters, how is the GPU responding, and what metrics, how the metrics are responding, and whether or not, for example, you still have enough, active warps and those type of things. So you can handpick maybe, a dozen or half a dozen of useful metrics, and then vary the parameters on entries, and then see how the system is operating. You can use inset compute from the CLI. You can use inset systems from the CLI. Inset systems allows you also to have SQL programming to load the database of the metrics. And so there's also Python scripts that you can use. So all the above is available, to you.
Yeah, and on the comment
points?
about the multiple reports, another thing is inside compute, you're able to load those reports and set a baseline. Let's say you have 5 runs, and you start with one, then you can, in the UI, you can easily compare all of them within the UI. All the graphs will show the different runs, and you can remove and add as many as you want to. So that's a good way as well. I agree with you, Seb. I think running on the command line, getting all those reports generated, loading it on the different tool, and comparing those. Next is, how do I print variable values in Compute Sanitizer? So there's no way of doing that. You're talking about maybe like adding printf into your code, but one idea that I was thinking is, now there's a feature to be able to do a core dump. So you can initiate a core dump that gets generated from the tool, from Compute Sanitizer. And then from there, you can load it into the debugger of your choice. So maybe that's a way. Maybe a little too intrusive, is because you need to generate it and then open the debugger. But if that's a way that might help the solution.
Yes, right, Rafi. That's the way we would advise people to do it. Is first run it into a sanitizer as a first step, and then with the dev generate core dump feature that is available since CUDA 11.6. And then you can load it in CUDA GDB, and you will be able to inspect the state of all threads that caused an issue, such as an out-of-band access. And then this way you can print the variable, see what state they are in, and hopefully that way figure out what the issue is with the code.
Thank you, Arlene. How do I transition from NVProf to Insight Systems? Actually, I think Holly created a nice blog for this with her team. Maybe Holly, you can post a link to the chat room. Maybe that could be helpful.
Well, if I can get to it, but yeah, I'll go and link to the how to transition page. The simplest way, if you're going from NVProf, which is the command line tool, is that actually the NSYS CLI has an NVProf command. So if you just prepend NSYS, NSYS, to the front of your NVProf command, will run the parts of NVProf that are available in NSYS. Now, all of the things aren't completely lined up. Some of the things that were in the old NVProf we decided didn't really fit in well with a sort of low overhead profiler. So not all of the options are available, but that will at least get you your initial data. And yeah, if you look around, I wrote a blog on specifically what to do in order to transition between the tools, and I'll put that link in the chat.
Thank you, Holly. The question. Again, another reminder about breakout rooms. So if you have any questions or any one-on-ones that you want to have, please sign up. I think Laura just posted the form again. Oh, I see one. Does Inside Visual Studio Code work on Linux and Windows? So yes and no. So it does work on Linux. It works on Mac as a host, meaning that you can do remote debugging from a Mac host to a Linux box, for example. It does run on Windows, however, and you cannot debug. So we expect users on Windows to use Inside Visual Studio Edition. And that will give you the full-blown debugging scenarios that we have on CUDA GDB. There.
And I think we can talk about the Jetson AR64 maybe.
Oh, sorry, what do you mean?
Well, to be able to run Visual Studio Code now on Jetson with Oran.
Oh, yeah, sure. Yeah,
Right,
good
so-
point.
right.
So with the new versions of CUDA tools, you can run the UI. Basically, you can run the UI natively on the Orange system. So you don't have to be, having a host machine to then, remotely debug into the
Right.
Jetson board. So now you can run, in this case, I think what Seb was alluding to is you can run Visual Studio Code on ARM because the UI from Microsoft runs on ARM. And then you install the extension inside Visual Studio Code edition. And then you'll be, on the Jetson device running Ubuntu, whatever version is 1804 or 2004 on ARM. And you'll be able to debug, edit everything on the device itself.
And this is coming soon, right?
And that is coming soon.
Right.
Can I access, moving on to the next question. Can I access the data in Insight Systems QD rep file?
Not directly from the QD rep file. That is the internal format that we use, and we make no promises not to change it. However, we do have the ability to take the data that's in that QD rep file and export it into a variety of formats that you can access more easily. The most popular one is that you can export it into an SQLite database, and then you can manipulate that database however you want. We recently released the export into the Arrow format, which is used by a lot of data mining, data analysis tools, as well as just CSV and text files and some other formats for at least the major features that are available in the tool.
Holly. Next up, Inside Visual Studio Code does it work on WSL2? So up until recently, Insight Systems, CUPD, Computed Sanitizer work on WSL2. We're still working on the debugger support as well as the profiler support. And I mentioned debugger.
That might be Rocket, this might be a case where we want to clarify the use case. I mean, we are working on the debugger support,
Right.
but just trying to make sure we're talking about WSL2, we're talking about kind of a Linux-based, runtime, and Visual Studio Code. I'd kind of like to maybe get an example of if they're doing Linux and they're using WSL2, what are they thinking of is going to be sort of their runtime environment for code, and I kind of want to make sure that we're not talking about different spots where we're running code on one platform and talking to WSL through a socket, or if they're all contained. I kind of like to get a feeling for the use case.
Yeah, it's I'm not sure how much we'll be able to get that. Just because
Let's cover the basic. Let's cover the basic. WSL2 running Visual Studio Code in a container, right, to debug CUDA, I think is probably the default.
Right. So running Visual Studio Code on a Windows box, let's say, and debugging onto a WSL2 It's something that we're planning to support. It's in the works, but we still need to get debugging support. Basically going into WSL and running CUDA GDB. That is still not supported, but we're working on it with Microsoft. Once we get over that and shipping, you'll be able to launch Visual Studio Code and be able to run CUDA GDB on the WSL and debug.
And just confirming that were they intending to run code on Windows and then connect to the Ubuntu container via sockets, or were we thinking that code would be running actually inside WSL2? Because to my current understanding, WSL doesn't allow graphical extensions like that. So I could be behind on WSL2's offerings, but I just want to make sure I know where code is running in the communication channel to the CUDA application and the debugger.
Yeah, I'm not sure, but there is GWSL, which is the UI portion, or not UI, but the graphical portion of it. So you can run with some performance limitation GL applications that are end up rendering on the Windows side. But yeah, I don't know what their use case is. I don't know if you saw it in the chat or not.
Yeah, Paul, if you wanted to kind of elaborate on what the runtime environment would be for your VS Code versus the WSL2 container running your CUDA application, that would help me to kind of clarify the communication channels and the dependencies on both sides of the communication.
Might be a good idea for the one-on-one, Steve. If this person, I'm not sure who you are, but if you want to have a one-on-one with Steve to get more details,
absolutely. We could definitely go to a breakout room and chat about this in detail.
Steve. I just, is there a possibility that the Insight extension for Visual Studio Code will be available on open extension marketplace like OpenVSX? Visual Studio Code seems to take too many resources to allow students to use it via SSH on our compute resources. It would be great if we could use an open version like the Code Server project. So I don't have Elton here, or Steve, you might be gone now to the breakout room, but I'm not over familiar with the Open VSX marketplace. We can look into that.
Yeah, I think we would need to investigate. We have done some investigations regarding Code Server, but that being said, right now our extensions are only on the Visual Studio Marketplace. We do also make the code available in open source, so there's some potential for roll your own, but I don't want to shoot from the hip there. I think we would need to kind of evaluate this more carefully before we could make a commitment.
The comment about it's taking too many resources, first time I hear about that, but okay, to use it via SSH on a compute resources. So is the concern that the server is taking too many resources? Because in the end, you don't want to run Visual Studio Code necessarily on the server. You can run it on the host side and then connect to the target. But anyways, it'll be good to. We can follow up on the Open VSX.
Yes.
Next up, we have a couple more. For performance evaluation, the specifics of what is occurring in an SM may be needed for an application. Are facilities available for this available? Sure, I understand that one. A couple very finely instrumented SMs per GPU.
I'm wondering if it's a use case of using CUPT in your application, right, to collect perf metrics. Rafi, don't you think?
Yeah, I'm not sure if I understand. What is occurring in an SM may be needed. Very finely instrumented SMs. Yeah, I mean, if going down the CUPT route can be one, but I wonder if Insight Compute can potentially give some of these information.
Robert, I think it's from the application itself. So I think, right, the specific was again. Well, maybe you're right. Maybe it's a tool that needs to collect for that. It's unclear if it's trying to program the collection of the metrics from within the application or to use a tool that can collect what the application is doing.
This might be a good question for Magnus, and I think
what's going on.
He's been pretty busy, but if you want to do a breakout room with Magnus, that might be. Magnus is the profiling one. That may be good.
Cycle by cycle basis.
It's cycle by cycle basis.
I mean, I'm wondering if yeah, I mean, I think you can collect the metrics if it's just using the tool inside compute or inside system with the GPU metric. You should be able to collect what's going on an SM with an expander.
Okay. Yeah, maybe this person can talk a little bit to Magnus to understand better.
Right, that's Gregory.
Yeah. Any suggestion for optimizing the performance of small matrix multiplication? So I think again the first item is use Insight Systems, right? Start there to get a high-level view of what's happening, any bottlenecks that could be possibly happening on the CPU side, even going down, of course, to the GPU. And then if you want to go down the route of looking at the kernel itself, if you feel like there's a kernel, then use Insight Compute to profile the kernel. All right, I'm being told that I need to wrap up. So we are going to bring everybody back to the main room, assuming everybody is back. Laura, I'm not sure if that's the case or not. Yeah, everybody should be back. I don't see Magnus yet, so he's probably still in a breakout room, busy. But everybody should be coming back. I'm going to be closing here in a little bit. Thank you, everybody, for coming in, participating with us. We hope you enjoyed it. I think everybody in our team takes pride for the tools that we develop, and we have our passion into, what we support and what we can do for you as a developer, so you can take, the most out of our NVIDIA platforms. Please review the sessions that we have here. We spend a lot of time on these, and it would be great if you can check them out. And also the overall catalog that's available on our nvidia.com/GTC site. Again, thank you for joining, and you can exit by closing on your browser.